First of all, who is new to ClickHouse? Nice. That's more than half the people. That's exactly what the meetups are for. But like, who's like a really experienced ClickHouse user? At least somebody has to be like, oh, nobody wants to say. I know a few people here like use ClickHouse already. So but anyway, I appreciate it. Also, I raised my hand twice, so who knows what I can do. All right, let's do a quick overview of ClickHouse, what it is, so everybody knows what we're talking about. ClickHouse is an open source, column-oriented, distributed rollout database. First of all, it is open source, like many other databases. It's actually been developed since 2009, which I always mention because a database, usually like the saying goes, that a database takes something like 7 years to mature. Like get all the edge cases out, don't have any split brains, especially a distributed database, don't lose any data, all this stuff. So it's been developed since 2009. It's been open source since 2016. So about 8 years or so, everybody has been able to use it. It's just Apache licensed, so everybody can use it. It is one of the most popular open source projects on GitHub. We have over, I probably need to update the slide, probably have more than 31,000 stars. Adrian, how many stars do we have on GitHub? You know this. Oh my God, this slide is so ancient. 35,000 stars. I even updated the slide this year. So like already this year, we've gained like 4,000 or 5,000 stars. Anyway, it has a lot of stars, much more than many other databases, because it's open source and Apache license and everybody can use it, and that's great. We also have a lot of contributors, now over 1,300, or I think now over 1,400, or maybe even over 1,500 contributors. Of course, many of them just like contributed like a little bit to the docs, but that's also a contribution, right? So like if you ever find something in the docs that you want to correct, even a spelling mistake, please correct it. If you scroll down in the docs, there is an edit this button. You can press it, you can correct something, and you can become a contributor to ClickHouse. We also do very frequent releases, which is also a little bit unusual in the database world. If you look around at like how frequently like a MySQL or Postgres does releases, or even Elasticsearch or something like that, they don't release that frequently. Like oftentimes, just maybe every 6 months, maybe even less. ClickHouse still does releases every month because we innovate quickly. We want to innovate quickly. We want to get features out there quickly. So there's actually really interesting, if you're more involved in ClickHouse, if you use ClickHouse in your day-to-day work, I do really recommend joining the monthly release calls. They're super funny. Alexei, our CTO, does it. He does the most amazing dry humor you've ever experienced. Like, you should just join for the humor. But of course, we also talk about all the new features and the new database. Fun fact, sometimes because it's open source, sometimes features get contributed that, I guess you could sort of debate, like, is this really a useful feature or not? Like, for example, somebody contributes a new codec for how to store data in ClickHouse, and sometimes you test the codec and it's like not any better than any of the existing codecs, but it's there now. So Alexei always has fun with that. Anyway, most features are really useful. Don't worry. Anyway, it's a column-oriented database. So traditional databases like MySQL or Postgres or Oracle or something like that is row-oriented. So you have tables and rows and columns like a spreadsheet, and then the rows just get stored in a file. So you just have basically a file that's just like one row and then another row, then another row. So that's pretty good if you want to read individual rows, or if you want to update individual rows. It is terrible if you want to do aggregations across columns, right? If you want to do like a sum of some column, you have to constantly jump like from in one row, find the column, then go to the next row, find the column, right? It's a lot of jumping. It's terrible. Basically, it's one read per row. It's absolutely terrible. Instead, what we have in ClickHouse is we turn this on the head, like on the side. So instead of storing the rows one after the other, we have files per column, and just the values for each column are going to be stored one after the other. And so that's great for doing aggregations, because if you're doing a sum of something or an average something, all the data that you need is in one file, and you can just read the file in one go as fast as possible. So it's much faster for aggregations. ClickHouse is much faster for aggregations than any row-oriented database, for example. We also do a few other things that make things fast. We have sorting. So for those of you that have not yet used ClickHouse, the first time you create a table in ClickHouse, you will discover that you can't just create a table. You have to create a table with a sorting key. You have to specify an order by clause. Now, I'll give you a secret. Technically, you can specify order by parentheses, like open, close, and it will do random sorting. But do not do this, because then you just get random sorting and you don't get good performance. Sort by something that the data should be sorted by, right? If you have time series data, for example, if you have some events or something like that, then there's going to be a timestamp column, and you should probably sort by the timestamp column because you will probably access the data by the timestamp. Your queries will be something like, do something with the data for the last 24 hours, 15 minutes, whatever, right? So you want it to be sorted in ClickHouse, so then ClickHouse knows where the data for the last 15 minutes or for the last 24 hours is, and it doesn't have to do a full table scan. Because no matter how many database optimizations we do, and we do a lot of performance optimization, if we have to do a full table scan, it will not be fast. Like, it's just going to take too long, if you have a lot of data, that is, which hopefully you do. And we do merges and stuff, but that's fine. It's a distributed database, right, as well. So the idea is that you can have a single instance of ClickHouse, and I do, like on my laptop. Like, for example, I have ClickHouse just running, and of course, I just have a single instance because it's just my laptop. And it's actually pretty useful to just use it locally for different things. But of course, if you want to have a proper setup, it's good to have it highly available with like several servers that are linked in a cluster, and you have replication, and you have sharding, and you have several masters, and it can be like cross-availability zones and cross-region, and like just never goes down. But importantly, ClickHouse is really designed to be an analytical database, right? So like in the database paradigm, it's an OLAP database. It is not an OLTP database. It is not a key value store. It is not a document database. It is not a search engine, right? It is an analytics database. It's built for analytics use cases. So it's built for aggregations, which are typically the basis for like visualizations, right? Like if you look at like a dashboard in Grafana or like Superset or Tableau or whatever, like you see any kind of charts, line charts, bar charts, doesn't matter, metrics, KPIs, those are all aggregations behind it, right? Like many values get aggregated into one value, or like one value per column, or like one value per point in the line chart, right? Like, so that's what ClickHouse is built for. And by the nature of the data that is usually used for analytics, most of the data is often immutable. Like if you have event data, for example, usually it's something that has already happened, so it's not going to change. Maybe all you have to do sometimes, some data was wrong and you have to like update it or delete it. So like there's a little bit of change, but it's not like you're going to rewrite the entire data set over and over and over. That in a very like one slide, that's like my one super slide that like explains everything there's to do about ClickHouse, and now we're done. Don't worry, I have like 10 more slides, I think, or a few more slides. Key features. 1, ClickHouse speaks SQL. I mentioned this because there are a lot of distributed databases that do not speak SQL. So Elasticsearch, for example, MongoDB, Cassandra, Redis, right? Like there are a lot of distributed databases that don't speak SQL because implementing SQL at scale in a distributed way is actually quite hard. Because if you think about SQL, right, like sure, if you have a query on a single table, like that's fine. But what if you have subqueries? And what if you have joins? And what if you have like 10 different joins with 5 subqueries? Like, how do you do this on a distributed database? It's actually not easy to do, right? If you do like some kind of naive implementation, then like all the nodes are going to send back and forth all the data over the network. You'll saturate the network. It will never finish. Everything will blow up, right? So you have to be a little bit careful of how you do that. ClickHouse has done the work. So it speaks SQL. Obviously, every SQL-speaking database has a little bit of their own dialect, right? Like MySQL is not PostgreSQL, it's not ClickHouse SQL, but we all follow the SQL like 2003, whatever standard, and then everybody has their own functions, especially for geo stuff, because somehow like every database has their own geo functions, also statistical functions and other functions, but mostly it's just standard SQL. And so pretty much everything that speaks standard SQL, all the query editors, all the UI visualization tools, BI frameworks, programming language libraries will mostly just work. And most of them these days have ClickHouse integrations, ClickHouse modules, ClickHouse dialects built in. And that's that. So that's very important. ClickHouse is optimized to be able to handle a lot of writes because, as you'll see in like one of the next slides, we have a lot of use cases that ClickHouse is typically being used for where you have a lot of writes. So on a single server, you can typically, on a bigger server, you're able to ingest millions of rows per second. And then, of course, you can have more servers and you can like scale this out to like whatever you need. The biggest server, the biggest cluster that is sort of known to me is about 4,000 servers for one use case. It's a cluster that runs some analytics AI stuff within ByteDance, which is better known as the creator of TikTok. So I never quite know whether this is like a use case that is good for society or not, but you know, I'm maybe too old. I don't know. You think about it. Fourth point, ClickHouse is highly efficient. Like one of the advantages of storing data in columns as well is that if you have files per column, then all of the data in that file is going to be the same data type, which is very, very good for compression. It is very hard to compress like an entire row when you have like 10 different data types. Like how do you compress a date time, which is then followed by some integers and then by some floats and some nulls? Like how do you do this? But in ClickHouse, a file is going to have just one data type, right? It's all going to be, let's say, timestamps. And then that compresses very well. Also because timestamps are often the same or very similar from one row to the next if you sort by time, right? If you think about a use case where you have like high frequency logs or trading data, like, or whatever, like clickstream data, right? Like many times the timestamp will basically go like, what's the date? The timestamp will be 2024 June, so 06, 19, 1854, right? And the next timestamp will probably be all these things, and then maybe the second will be different. So why store the year, the month, the day, all the time for every one of the values? All you can do is you can just store the difference between one timestamp and the next timestamp. And the difference might be 1 millisecond. The difference might be 0. And so that gets super efficient. So typically, ClickHouse gets very, very good compression on uncompressed data. You just put in some CSV, for example. Oftentimes, you get like 20 times compression. So if a terabyte of CSV data becomes, I'm terrible at math, 50 gigabyte, I guess, in ClickHouse, right? Really depends on the type of data and the structure and how well it compresses, but really, really, really worth it. That's where a lot of the cost savings come from on storage with ClickHouse. Much better compression than other databases. But also, if you're able to store the same data, the same information in less space, you will make the queries faster because the queries don't need to access and read so much data. Because many times the limiting factor, one of the limiting factors on query speed is how much data the query has to read physically from disk or from object storage. And if you can reduce that, the query just gets faster. Also, of course, you can use the CPU more because you can just throw values in there faster and so on. Anyway, fast queries. We have very fast queries because we can read the data so quickly, and we use like all the modern CPU instructions that are built to take many different values in one go and just produce one result. So pretty much all the standard functions are optimized down to the assembly level in ClickHouse. And then the last thing also, I mentioned joins and lookups because many other distributed databases do not have joins and lookups, or they do not have dynamic, like completely free joins and lookups. Like in MongoDB or in Elasticsearch, like there are such features. Like ClickHouse has this like parent-child relationship, or I think now Elasticsearch has this parent-child relationship, which I think they've now renamed to something else. By the way, I used to work for Elastic for many, many years, so I use that example a lot. But you have to predefine it. In ClickHouse, you don't. In ClickHouse, you can just have different tables, and you can join them in query time whenever you want. And that can be very useful, especially if you have like a business analytics use case where you have some kind of like star schema or something like that, where you have fact tables and dimension tables that you do need to join together. Obviously, if you don't have to do joins, it will always be faster, right? Like if you can do your joins at ingest time, if you can denormalize your data, please do, right? It's going to be faster. But sometimes it doesn't make any sense. Often it doesn't make any sense. And then you just have to have different tables. All right. Who uses ClickHouse? Well, here's a few examples, and I like to bucket them into sort of these 3 different areas. Number 1, we have user-facing analytics. So my example, when somebody asks me, like my parents ask me, what do you do? It's hard to explain, right? Like I'm sure many of you have the same problem. And my go-to at ClickHouse is I tell the Spotify use case. So who uses Spotify here? Who has a Spotify account? Not even that many. Does everybody else have Apple Music or Deezer, or what do you guys have? Who knows? Tell me after. But anyway, Spotify, of course, collects all the data about what people are listening to, right? Like our data gets anonymized and everything, but it gets collected. And then one of the users is to give access to this data in anonymized, aggregated form to the music industry. So if you're like a music executive, you're an analyst for like a record label, for like Warner, Sony, or whatever, you get access to this data. There's something called Spotify for Artists, like a mobile app and a web app. You can log in and you can see like your artists, who is listening to your artists, who are they, where are they, how old are they roughly, what else are they listening to, and this is all powered by ClickHouse. And it's like the sort of like the perfect use case for ClickHouse because you have real-time writes, right? The data just comes in all the time, like in real time. You also have real-time reads, and you have a lot of concurrent reads, right? Like if like what's the current hot artist? Anybody? Taylor Swift, I guess? I don't know. When the current hot artist drops a new album, the entire music industry is there refreshing the dashboards. seeing like, oh, like who's listening to that? Do we have some overlap? Do we need to like push something? Do we need to promo something? All that. Anyway, that's my use case. So by the way, if anybody asks you what you've done tonight, it's like you've listened to the technology that powers that. But there's a lot of other use cases, right? Similar user-facing analytics use cases you have, for example, at Bloomberg, which just has financial data, then exposes it through the Bloomberg terminal. Everybody in finance knows the Bloomberg terminal. Everybody uses it, or most people use it. And part of that is powered by ClickHouse, because again, real-time financial data is usually real-time, and you need access to it in real time to make decisions about what to buy and what to sell. And then there are a lot of software companies like Twilio or Content Square or Checkout that use ClickHouse to build some kind of real-time analytics experience for their customers, right? You're a customer of like Twilio, you use Twilio, and you of course want to know like what is Twilio doing for me? And what Twilio does like is they send emails and text messages and stuff like this for other people. And so of course you want to know how many emails has Twilio sent and how many were opened and how many bounced and like all these things, right? Like you want to know this and you want to know it in real time, because if there's a problem, you want to fix it in real time. So that's powered by ClickHouse. Then we have in the middle internal use cases, very similar, but internal. So like Walmart, for example, has this giant data warehouse, 300 petabyte of data. Many of it is not super important, but there's some data that is very important and that they need real-time access to, or that they expose to like APIs and dashboards to suppliers, for example, or store managers. And so ClickHouse is like a speed layer on top of their giant data warehouse. And they do the fast things in ClickHouse and they do the slow things in their data warehouse, which it's Walmart, so it's Hadoop, but anyway. Deutsche Bank has a big financial data warehouse with financial data going back to 1999 or ClickHouse. And then lastly, the first two buckets are sort of business data, right? Spotify's business data is the music data, what people are listening to. Deutsche Bank's business data is the financial data. But then the third bucket is like technical data. So pretty much every company has technical data. Everybody has logs, metrics, traces, network logs, flow logs, like those kind of things. And at scale, this also often gets stored in ClickHouse these days. So Cloudflare, for example, is running thousands of machines of ClickHouse for all their HTTP logs, DNS logs, error logs, all kinds of things. GitLab moved all their tracing to ClickHouse. Netflix and Disney are using it for CDN analytics. So any like large-scale monitoring of systems, large-scale observability time series data is these days often done with ClickHouse. Also, a lot of observability companies are these days based on ClickHouse. Actually, sort of Postdoc, I guess, is in that area. Like they've built a product, an observability product, a product analytics product on top of ClickHouse, or people like Chronosphere or BetterStack or Instana or those like different players have built on ClickHouse. Even things like Fortinet and QRadar, like sort of traditional like products that typically don't change that quickly, now have ClickHouse backends because the data volumes just keep increasing. All right, that was the logo slide. Don't like talking too much about benchmarks, but of course, one of the reasons why people use ClickHouse because it's much faster than other things. So we're pretty open about this. We do our own benchmarks under this link. And if I click on it, do we get it? Yep, I do my own benchmarks. We do our own benchmarks. We have this massive benchmarking suite that we run on everything. And just to prove that we're honest, we are not even #1. But if you look up Umbra, it's like a research system from like University of Munich. It's very cool, but like it's maybe not really something that you can directly use. But then, of course, you have ClickHouse and then like a bunch of others there. So we're quite open about it, but always, of course, do your own benchmarking on your, how do I get back? Do your own bench, there we go. Do your own benchmarking on your own data, because otherwise benchmarking is sometimes bench marketing. We also have this GitHub issue where we just collect benchmarks that involve ClickHouse, and everybody can also contribute to this issue, and many people do. All right. Quickly, what does it look like when you actually use ClickHouse? Well, I already sort of mentioned tables, rows, columns. So in ClickHouse, very similar to anybody that has worked with any SQL databases, you have your create tables, you create your tables, you have your columns. Now, in ClickHouse, we have a lot of very more advanced columns. Like we don't just have the standard SQL data types. We also have special things, like, for example, this low cardinality data type. That's just dictionary encoding for a string. So here, for example, a tenant, usually the same tenant will appear over and over. The same value will appear over and over, and it would be a bit of a waste to store the same string over and over and over. So instead, you just store it in a map. You have like a dictionary, and you just store the values where it appears without storing the value itself. We have arrays and maps and tuples and lots of different data types. So anything you can typically get it into ClickHouse. And as I mentioned, you do need to specify an order by key. So in this sort of very generic example where you have an events table, where you have a timestamp and you have a tenant. So the assumption here is that you have data from several different tenants that should be kept separate, and then all of the data is time series. It would make sense to have a sorting key like this, where all of the data is sorted by tenant first. So all the data for a particular tenant is stored continuously together. And then within that, it's sorted by timestamp. And timestamp is probably very fine granularity, and so it's going to give you the perfect sorting order. A few other things that we can also do is we can have like replacing merge tree engines and aggregating merge tree engines, where you can go and you can have like a row and you can insert another row that has the same key and that replaces the existing rows. Like you can sort of modify data or do like roll-ups with the aggregating merge tree engine. But let's get not too much into that. Inserts, we just have normal insert into statements that you can use. Typically, though, to be honest, you will probably use other tools that will just insert into ClickHouse, or you will like insert in batch fashion from wherever your data is in Parquet files in S3. You can just insert with something like this, insert into table, select from S3. Maybe you have your data in a MySQL database. So you go and like do insert into select from MySQL. ClickHouse can connect to MySQL and just read from MySQL, or from Postgres, or from many other things. Or there's a ton of ETL tools and streaming tools, and there's Spark and Flink and everything that can write into ClickHouse. Technically, all of them under the hood use this, but you don't see it. And then just real quick, sort of to recap a bit, like what to use ClickHouse for and what not to use ClickHouse for. So I always like to give these examples, and I like to start with the things that you should not do with ClickHouse. So as I mentioned, ClickHouse is a columnar database. So every column gets its own set of files. And then if you do select star, that sort of defeats the purpose, because now we're just opening all of the files for all of the columns, and it's much more expensive to read from all of the files. Instead, if we had all the data in one file, it would be faster. So select star is not really the use case. Now, it's OK to do this, right? Like it's OK to do this, but not as the main use case. So for example, you might have a dashboard where you have a bunch of like charts at the top that are aggregations, and that's what ClickHouse is for. And then maybe you have a table underneath where you actually have the raw data. And of course, the table underneath is the select star, but that's not the main problem, right? Like that's the easy one. The hard one is to do the aggregations at the top. So don't do select star, at least not too often. It's going to work. It's going to be fast, but it's not what it's built for. And the second thing is ClickHouse is built to be able to process a lot of values, a lot of rows quickly. So if you do something like select only a single row, right? If this is a kind of UUID that's unique to like one particular row, identifies one particular row, then that's not going to be so efficient either in ClickHouse, because under the hood, ClickHouse actually never reads just a single value, just a single row. ClickHouse will always read at least 8,192 values by default, which also happens very, very quickly. But again, it's just not as efficient, right? Like this is more like a key value query. Like I want to get like one value out of the database. There are much better systems for that. Like you can use like Redis, and it's going to be so much faster. But again, it's going to be fast in ClickHouse, it's going to work in ClickHouse. It's just not maybe the main thing that you should use ClickHouse for. If you just need to get like the latest value of something, but you usually do aggregations, that's of course fine. The majority of the ClickHouse queries should be something like the aggregation here below, right? You select one or several columns, do an aggregation, average, sum, min, max, whatever, several more columns, doesn't matter, from a table, and then you have some kind of broadish selector, right? Like here we look at everything for 2022, or maybe it's the last 30 days, or maybe it's just like one tenant, or maybe it's something, right? Like you select a decent amount of values that you want to aggregate on quickly, that you want to process quickly, because that's hard in other databases, and it's easier, let's say faster in ClickHouse. That's what people use ClickHouse for. We also have something called materialized views. We have normal views that are just stored queries, saved queries, but actually materialized views are quite interesting. So materialized views in ClickHouse are very different from materialized views in pretty much any other database, so just be careful. Materialized views in ClickHouse are insert triggers. So if you insert into a table, the same insert will go through the materialized view query, which can be like an aggregation, group by, something, some kind of pre-computation, and the result will be put into a different table. And these two are always going to be in sync. So the idea is that you insert your raw data into one table, and then it gets materialized with some kind of pre-computation into another table, and then they're always in sync. And depending on what you need from the data, you can query one or the other, and it can make a lot of things much, much, much faster. All right, just really quickly, we have a lot of integrations. ecosystem. Since we're a modern database, we have an HTTP interface. I always get surprised how like MySQL doesn't have an HTTP interface. It's not that hard to add, and why can you not just send queries over HTTP, but whatever. In ClickHouse, you can. We have an HTTP interface, a native TCP interface. We have a command line interface. We have JDBC drivers, ODBC drivers, client libraries for everything, lots of tools support getting data into ClickHouse, various ETL tools, streaming tools. You can get data from other databases. You can use any query editor you want. It's just text at the end of the day. And these days, we pretty much support every visualization tool out there, both the, let's say, good open source ones like Grafana Superset Metabase, as well as the slightly less good, I don't want to say evil, proprietary ones like Tableau, Power BI, and others. But we support all of them. It's all good. And just lastly, 2 ways of running ClickHouse, right? Like one, you can run ClickHouse yourself, right? Download open source, just run the open source on some servers with some disk attached. Or you can use ClickHouse Cloud, which is the managed service that we run, right? This is how I get paid. And there we have like this decoupled storage compute architecture, which is very common to cloud databases these days, where we have object storage under the hood, compute on top, the compute becomes stateless, object storage is cheap, and then we just provide access to it. And lastly, if you want to learn more, then go to clickhouse.com/learn. That's where our learning page, ClickHouse Academy, I think it's called, is these days. We have a lot of different courses. We run, if you're new to ClickHouse, I really recommend we run like a 6-hour fundamentals training. It's all free. All training is free at ClickHouse. We run like a 6-hour ClickHouse fundamentals course. It's delivered live, usually once a month, I think, 2 times 3 hours in 2 days. Of course, also recordings are available. We also now have a longer, I believe, 12 hours ClickHouse developer course if you want to go even deeper. And we now also have ClickHouse certification. So if any of you want to get that badge and put it on LinkedIn, maybe it helps with the job search next time you need a job or you're bored of your current one, then you can get certified and be a certified ClickHouse developer. Any questions? Not such a chatty bunch today, right? Like, all right, maybe you're all just stunned by ClickHouse, or maybe I just bored everybody. Ah, yeah, one question, okay. Yes, it has an explain command, super useful for query optimization. The explain command will tell you things like how much data are we reading from a table? So like, are we reading, to answer this query, are we reading like 10% of the data from a table, or 1%, or 100%? So that's usually my first go-to. When a query is slow, I check like how much data is it reading from each table. Because for example, if the sorting key does not match the query, like if you're sorting by time, but the query is not by time, yeah, ClickHouse has to do a full table scan, and then you will basically see that it's reading 100% of the data from a table, and then you know where the problem is. That's no, it's not like based on table. Like it will tell you what it's. It will do the index analysis. So the first step of running a query in ClickHouse is ClickHouse will get the query. It will look at the things like work condition, and it will do the index analysis. So the index is always in memory. The sorting keys is always in memory. And it will see, to answer this query, I have to read all of these parts of the data, or like we call them granules. So we have to read all of these granules. And if you do explain, and it will like display it in like a tree manner, where you can see like it's like we're going to read this much data from this table and this much data from that table. And if there's multiple keys on a table, like you have a partitioning key and a sorting key and other keys, like you will also see like what key does what, like how much it filters down the data. You can go further than that. Like you can do explain pipeline, where like it will actually show you the query pipelines and like how many threads each step is using. And sometimes that's quite useful. Or the ultimate tool for if you really want to know what's going on, you can do set send logs level equals trace, and then you run a query and it will give you a giant wall of text every single step that it's doing. That's like the ultimate thing. We can see exactly how much time is it spending, and it's all like timestamps. So you can see how much time is it spending on index analysis, how much time is it spending reading the data, how much time is it spending aggregating the data, and all that. So that's a large part of my day today, actually doing that with helping customers do exactly that. Cool. Yeah. I wouldn't say that ClickHouse is an operational database, because ClickHouse does not have ACID. It does not have foreign keys. It does not have unique keys. And so I wouldn't use it to power like a bank ledger application, right, for example. But ClickHouse is mature and secure in a way that if you insert into ClickHouse, it will stay in ClickHouse, it will not get lost, you'll not get a split brain if you have it all set up correctly. And so like it is very like durable and secure and everything. So like in Spotify's case, that's good enough, right? Like they don't need ACID like to do these inserts of the different streams, right? Like it's fine. There's no need to have foreign keys or unique keys. Like the data is correct. Even if the data would be slightly incorrect in that case, like it's fine, right? You miss a few listens, like it's not gonna affect the results. But we have a lot of use cases where it has to be absolutely correct, like the Deutsche Bank use case, right? Like it has to be correct. The financial data warehouse is being relied on to run trading algorithms, and if you get it wrong, like it could cost quite a lot of money. Yes, but it's not an operation database. We have a lot of use cases where ClickHouse, depending on the type of data, ClickHouse might be a complement to an operational database. You might have a Postgres or MySQL or something like that. Have your data there. We actually do need all these guarantees, and then replicate the data from there into ClickHouse. We do have that quite a lot. We also have people that have a data warehouse, like Walmart has this giant data warehouse, which is more like Athena, right? Like you just have cheap object storage. You just put a bunch of data in there in Parquet files or Iceberg or whatever. And then sometimes you query it, and then you might have ClickHouse on top for like the more like real-time data. If you look at some of our marketing, I don't like to use our newest marketing, but our newest marketing is that ClickHouse can be like a real-time data warehouse. So I guess like sort of like a mix, like in between a traditional data warehouse, which is more like slower, and an actual database that's like where everything is like, or most of it is in memory and like on local disk. So some like a mix sort of like in between. Yeah. Okay, let's go to the next speaker, I think. I'm around for questions afterwards. Hope this was useful for anybody that was new to ClickHouse, and hopefully I didn't talk too fast. Thank you.